All right, so moving on from circles now, we're going to be looking at ellipses. And what an ellipse is it's an oval. It's kind of a circle that's, a little bit flatter. Okay, but it's still got that circular shape. So there's different things that do have this shape in the world, or in the universe, I should say. Earth's orbit is probably the coolest example. I would say the coolest example of this. There's many others that you would see, and we're going to talk about like graphing these and different things about them. So what an ellipse, when you're graphing an ellipse, first thing you're going to do is look at the equation, which this is the equation for it. So as you see, it's different from the circle. Instead of being equal to the radius, it's equal to 1. And what you have is you have two fractions with an addition between them. So you have x minus h squared all over a squared plus y minus k squared all over b squared equals 1. And that addition is important because when we talk about hyperbolas, okay? Now, the hk is again your center, so that's kind of your starting point when you graph, okay? Now the distance in which you move left and right and up and down represent the number underneath, okay? Whatever the x is divided by, you take the square root of it, and that's how much you're moving left and right. Okay, so underneath the x is your left and right. Underneath the y is your up and down. Okay, so you take the square root of that number and then you move that far up and down. Okay, and so this has two different types because you can either have it opening longer along the x-axis, or it could be opening longer along the y-axis. If it's opening longer across the x-axis, that means that the a is the bigger number, or the one underneath the x is the bigger number. If it's opening more over the y-axis, that means that under the y is the bigger number. Okay, and this is important when we talk about the foci of these, and which we'll talk about a little bit later. But first, we want to graph. So when you're graphing, first thing you want to do is identify, okay, where's the center? Well, since the x and y are not being added, anything's added inside that the squared, it's at 0, 0. So our center, we're going to start at 0, 0. Now what we're going to do is that we're going to take the square root of each number underneath. The square root of 4 is 2. The square root of 16 is 4. So along the x-axis, we're going to move 2. So 1, 2, put a dot. 1, 2, put a dot. Okay. And now along the y-axis, we're going to move up and down 4. 4, 4. Okay, and this is going from the center. Now, as you see, these are our points, and then all we have to do is just connect them using an arc. And as you see, we've created an ellipse. Okay. And so let's do another example here. So let's say we have x minus 3 squared all over, let's try to keep it nice, 25, and we're going to add that to y plus 2 squared all over, let's go 1, is equal to 1. Okay. And so what you'll do first thing is that you will go to your center, which in this case will be at 3, comma negative 2. Okay, remember you changed the signs, so we go 3, negative 2, which is down there. Okay. Now along the x-axis, we're going to be moving square root of 25, which is 5. So we're going to be moving 5 to both sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And then along the y-axis, square root of 1 is 1. So as you see, this is a very flat looking ellipse. Okay. And so that's what that one would look like. So that would be your ellipse for that equation. Okay. So that's graphing them. So it's pretty simple, pretty straightforward. Okay, now the foci. The foci is found by taking the larger number minus the smaller number. Okay, so it's the larger number minus the smaller number. Okay, and what you do to find the foci is that from the center you're going to add whatever C is, whatever you get for C, add it and then subtract it. Now, if the number underneath the x is larger, you're going to use this top one. Okay, so if your ellipse looks like this, how it's more spread out. If it's more up and down, you're going to use this one. Okay, so if the y has the bigger number, you're going to use that second one. You're going to adjust the y value instead of the x. Okay, so whichever one's the bigger number, that's the one that's going to get added the c to. Okay, so looking at this one, first thing we want to do is find our c. So what we'll do is that we'll take the a squared minus the b squared. So 49 minus 36, that gets us 13, which means c would be the square root of 13. So c is the square root of 13. Now where is the center of this? The center is at 0, 0. Okay. So the center of that ellipse is at 0, 0. So now which one's bigger? The number underneath the x is bigger. So that means we're going to add and subtract along the x. So we're going to go 0 plus 13, which will get 13, comma 0 would be 1 foci, and then 0 minus 13, square root 13. Get you your second one. So your foci would be a positive root 13, 0, and a negative root 13, 0. Okay, so that's your foci. So you go the numbers underneath subtracted. Okay, all right. So finding the foci of this one. Okay, so what we'll do again is that we'll take the larger 25, subtract it by 9, and we get 16. Square root of 16 is 4. Now we're going to start at our center, 0, 0. And now are we going to add it to the x or the y? Well, which one has the bigger number? The y has the bigger number underneath, which means we're going to add and subtract 4 to the y value. So your foci would be at 0, 4 and at 0, negative 4. Okay. And so that is where your foci would be. All right, so your IRAT. Your IRAT for these, you're going to graph each of these and find the foci for both. Okay, so graph both of these and find what the foci would have to be. Okay. Yep. So remember to take the square root of the bottom when you move it left and right, and remember to find the foci. It's a squared minus b squared equals c squared, and you're going to add and subtract c, which would be the square root of this number, to both parts. Okay. So graph and find the foci.